the Pythagorean theorem, which is an ancient equation, okay, and one of the most famous. And it's used to find missing sides in right angle triangles, okay? So right angle triangles contain one angle that measures 90 degrees. The longest side is always across from the 90-degree angle and has that special name, hypotenuse, okay? And the other two sides are called the legs, okay? It doesn't matter which one's leg 1 and which one's leg 2, but the other ones are called the legs. And the legs form a 90-degree angle. A famous mathematician, Pythagoras, discovered an amazing property of right triangles. So that property he found was the areas off the sides of the two legs is equal to the area of the square made off the hypotenuse. Okay? So if you find the area of the square off this leg, just by counting the squares, that's 9 square units. And then find the area off this leg, just by counting the number of squares. It's 16 square units. And if you add them together, that should be the area off of the hypotenuse. And if you add up all the square units here, it's 5 by 5, so it's 25 units squared, and 15 running back easier. So 9 plus 16 is equal to 25. That means this is a right angle triangle. Okay? So the areas off the sides of the legs equals the area off the square of the hypotenuse. Okay? You add these areas together, you get that area. So area 1, area 2, area 3, area 1 plus area 2 is area 3. And then once they figured out that was cool, they tried to make it into a nicer equation. So we always call the side length, so not the area, but the side length across from the hypotenuse, we use the letter C for it. And if this is a square, then both sides are C. Does everyone agree? So the area of this could be found by doing length times width, but the length and the width are both C. So another way of writing the area is C squared. You see that? Because the length and width are both the same. They're both C. C times C, back to our exponent laws, is C to the power of 2, because you keep the base and add the exponents of 3 to 1. Okay? If we do the same thing over here, we could call this side A, and this will also be side A. So if I want the area of rectangle 1 here, it's length times width. I don't need the bracket. Length times width, which is A times A, which is A squared. And then if we call this length here of the other leg B, then both these sides would be B. And the area of this one would be B to the power of 2. Good. Okay, so this is where, so the area of this one, C squared, is equal to the sum of these areas, so A squared plus B squared. So that's where that formula came from. And that formula is the Pythagorean theorem. Okay? So it all had to do with areas, but we end up using it to find side lengths mostly, not areas. Okay? So C is the hypotenuse of the triangle, A and B are the legs of the triangle. So remember, this one that's on its own side always has to be the hypotenuse. The longest side, okay? Remember that this amazing property only works for right angle triangles, okay? It only works for right triangles. So you can't just use it on any triangle, it has to have a right angle. Okay, and then this is in words. In words, the square of the hypotenuse, which means C squared, of a right triangle is equal to the sum of the squares of the other two sides, A squared plus B squared. Sum means add. Okay, so there it is in words. The Pythagorean theorem, combined with what we know about solving equations, can be used to find missing sides of right triangles. Okay? You need a calculator, a pencil. Have those things? All right, so determine the height of the hypotenuse to the nearest tenth of an inch. Sorry, the length of the hypotenuse, my bad. Determine the length of the hypotenuse to the nearest tenth of an inch. So, step one. Josh, turn page over. Label the three sides, C, A, and B. Okay? So C is always across from the right angle.
It doesn't matter what A.
It doesn't matter what A and B are, perfect. Okay, so I always usually do A as the bottom and B as the side, but it doesn't matter. C is the one that matters. It has to be across from the right angle. So step one is you label your triangle. Okay? Step two, you write out the formula. C squared equals A squared plus B squared. So this is step one, just labeling your triangle. Step two, write the formula. Step three, substitute into the formula. So C is not being called C in this question, it's being called H for hypotenuse, so H squared. So we replace C with H. A is 12. So substitute using brackets 12 squared. B is 8 plus 8 squared. Step 4, do the squares. So 12 squared is 144. 8 squared is 64. And make sure you know how to find that button on your calculator. Tutors can help if you don't know. So type 12 squared in and make sure you get 144, because sometimes you'll get decimal numbers and you won't just know how to do them in your head. Okay. Then we add the squares. So 144 plus 64 is going to be 208. And then how do we get h by itself if we have h squared right now? What do we do to both sides? I want to undo squared. Yeah, square root. Yay, both sides because it's an equation. So then finally we get h. And then usually we use a dot above the equal sign because usually it's not a perfect square. Approximately 14, so a dot, 14.4. And then look for the units in the question, inches. So that means this side is 14.4 inches. Now, remember the hypotenuse always has to be the longest side. So what I do is if I'm finding the hypotenuse, I make sure it's longer than the other ones. Okay? If it's not, then I've messed up my calculation. Or if I'm solving for a leg, I make sure it's shorter than the hypotenuse. Okay? All right. How far up the wall does the ladder reach? So X. Step 1, label the three sides C, A, and B. So here's my right angle. So C is the side across from the right angle. Everyone good? A and B, it doesn't matter which one's which. Then you write the formula down. C squared equals A squared plus B squared. Then you put the numbers and or letter in the right spot. So do we know C in this one? Yep, it's 11. So 11 squared equals, do we know A? Yep. 4 squared plus, and they're calling B X. So that's my substitute step. Now I work the squares out on my calculator, or in my brain. So 11 to the power of 2, or 11 times 11 is 121. 4 times 4 is 16. And I want to get X by itself. So what would I do first to both sides? Not yet. I'm going to get X by itself. Minus 16, very good. So there's my 0 pair, gone off that side. So I've got X squared on this side. That's going to be 105. And then how do I get? Now I square root, right? Because I've got X squared all by itself on one side. So square root both sides. And I'm going to get X is approximately, so I have to find out the square root of 105. 10.25 or 10.3 meters. Put it on your triangle so you can make sure it makes sense. It's smaller than the hypotenuse, so we probably did it right. Okay, legs have to be smaller than the hypotenuse. So the ladder reaches 10.25 meters of the wall. Determine the perimeter of the triangle. We talked about perimeter in Unit 1. Does anyone remember how you find a perimeter of something? What does that word mean, if you see it? Add up the outside edges. Okay. So we know 2 of them. We don't know the third one. We're going to have to find the third one first before we can find the perimeter. Everyone agree? So label the 3 sides. C, this was called B, so I'll call this one A. So step 1, label your sides. Step 2, write down the formula. And I'll let you. If I'm substituting, 34 squared. Everyone get to this step? Okay, so what do I do next from here? Yes.
You have to do minus.
You do. Awesome. There's my 0 pairs on. Thank you. And square root both sides. And what do you get for B? This is a perfect square, right? 16. Yep. 16 inches exactly. But then they ask for the perimeter, so you're gonna add up 30, 34, and 16. 16 makes sense because it's smaller than the hypotenuse. 80 inches. So therefore perimeter is 80 inches. Okay? Be careful for this if it's an EQAO. One of the tricks they'll put in is they'll put in 16 because you're going to forget to find the perimeter. So that's where you highlighted what you can't because it's on a computer. Write down on your whiteboard important words, okay, to remember. So, because I find when you guys write a multiple choice test, if you get to 16 and one of the answers is 16, you're like, oh good, and you tap on it, right? So you have to be careful because they've thought of all the things you're going to do wrong. And those are all the other answers. Okay? So you can read carefully and double check, take your time. Okay, this was a EQAO question on the non-applied EQAO a couple of years ago. So see if you can do that. Okay, so I heard Cole saying they're both on the same side of the number, so I don't have to add or subtract both sides, or I don't have to subtract from both sides. I just add the squares together. And now I square root. Four. Nope. $11.7.
So 12.
So 12. Okay. And it says which is the closest to the value of C. And one of these answers will be if you have subtracted the 100 minus 36. Okay. Here's an academic EQAO question from a couple years ago. Same thing, so I'm going to give you some time to try. Okay, so it says the 5 kilometers of highway between city X and city Y is closed. Okay, so you can't go that way. There are 2 possible detour routes, one through town A and the other through town B, as shown below. So you can tell just by looking at it that this one's going to be way longer than that one. How much shorter is the detour through town B than through town A? So in order to know that, you need to know how far this detour is, which would be this plus this. And then you have to know how long this detour is, which would be this plus this. All right, so here's our triangle 1. Do that right, I guess. And this is triangle 2. We're going to have to do Pythagorean here for each of them. So for triangle 1, here's my right angle, which means this is side C, this is A, and this is B. So I don't know C. A for me is 5. B for me is 12. Do my squares. My squares are on the same side, so I just add them together now. So it's going to be 1, 6, 9. Square root both sides. And you get C to be 13 kilometers. Put it on your picture and make sure it makes sense. It has to be the longest side because it happens to be the hypotenuse, and it is. So then we can also find detour 1. Detour A, we can call it, is going to be 12 plus 13, which is 25. Okay. Kilometers. And now we have to deal with triangle 2. So this time the right angle's here. So when I label the sides, 5 is the hypotenuse, C, A, and B. The C is always across from the right angle. Write down the formula. fill in the numbers we know. So this time we know C and A, but we don't know B. Then you figure out your squares. Now they're not, both numbers are not on the same side, so I have to make a 0 there so that I can get B squared by itself. So subtract 9 on both sides. 0 there. Minus 9 is 16. Square root. And we get B is 4 kilometers. Sorry, 4 kilometers. Which makes sense because it's less than 5. So D2 or B is going to be 4 plus 3, which is 7 kilometers. Notice how 7 kilometers is there, but that's not the answer, right? The answer is how much shorter, sorry, is the detour through town B than town A? So I have to do 25 kilometers, subtract 7 kilometers, and that gives me 18 kilometers, which is D. Okay? And then the last one was EQA1 grade 9 applied. So I'll give you time to try that one. It wants the slope of the ladder. And what's the formula for slope before you start? Rise over run. And what do we not know out of the rise and the run? The rise. So you're going to have to use. So here's my right angle down there. I don't show it to you, but you assume it. So this is my C, A, and B is going to be the rise, but I don't know. This is the run. So 13 squared plus 5 squared plus 3 squared. On opposite sides, so you can go zero here, there. B is 12 meters, which makes sense because it's smaller than 13. Yeah. So how do you get the slope then? Awesome. And does that reduce? No. So, if it was multiple choice, they might tell you because it's a ladder and not like a just a line, they might change it to a decimal, 2.4. So be aware that it'll either be 12 over 5 or 2.4 you're looking for if it's multiple choice. See how their EQAO is famous for like putting two things together. So they're testing if you can do the Pythagorean theorem. They're also testing if you know the slope formula in the same question. Okay. All right, so